Okay, so I'm going to do your test review sheet. It's 15 questions, so it shouldn't take that long, hopefully. So let's get this started. The sixth grade won a contest and received $480. The money is to be equally distributed among all the students. There are 5 classrooms with 15 students in each class. How much will each student receive? Alright, so what do we have here? What we have here, and I'm going to turn my TV volume down. So, sorry. You want to share the $480 with all the students in the sixth grade. Well, you first have to determine how many students there are. There are 5 classrooms. Okay, 5 classrooms. And there are 15 kids in each classroom, giving you a total of 75 students. Small school. So now, all you have to do is divide 480 by 75, and you get that each student will get $6.40. Okay. I'm not going to do the division because that's simple enough, but okay. So the main process was figuring out that there were 75 students first, and then divide 480 by 75. Okay. 2/5 of all the students in the class are girls. So, and 1/3 of those girls are Korean. So what fraction of the class are Korean girls? So you want to take a piece of a piece. So let's see if I can, although the question doesn't ask you to draw a model, I will try to draw a model. So here is the classroom. Okay. 1, 2, 3, 4, and 5 is a little too big. So let's make it a little smaller. Okay. There's 5. There's your classroom. 2/5 of that classroom are girls. So this 2 shaded box represents the part of the class that are girls. And out of those 2 parts, 1/3 of that, okay, which would be just by drawing it, that part, which is 1/3 of these 2 boxes, are Korean. So as a fraction, you want to represent this, obviously, with a fraction. So it's a piece of a piece. You're taking a little piece of that piece, which represents the amount of girls in the classroom. So you're taking 1/3, which is this 1/3 of 2/5. 1/3 of 2/5 is written this way, and you want to change it to obviously 1/3 times 2/5. And multiplication just means a fraction is numerator times numerator, so you get 2 over denominator times denominator, 2/15. So 2/15 is actually what this little piece is. So 2/15 of the class are Korean girls. Okay. 3. 9 pies were bought for the school dance. If they had to be cutting if they are to be cutting 1/6 slices, how many students can get a slice? Well, of the pie. So let's draw 1 pie because 9 is a lot. So if you have 1 pizza pie, a rectangular one, by the way, 1, 2, 3, 4, 5, 6, 7, 8, 9. So if you had a rectangular pie and you cut into 6s, and I don't know why I'm cutting into 9s, so I gotta erase this. So let's erase 3. So here's your pie, and you cut it into 6 slices. 1, 2, 3, 4, 5, 6. So there's 6 slices here. So if you did the same thing with 9 pies, okay, you would have your 9 pies, and each pie is cut into 6 slices. You would be able to fit you would be able to feed 54 students. Okay? That was easy enough. Okay, so let's go on to my next question, which is Tony weighs 78.347 kilos. Larry weighs 83.09 kilos. What's the difference in weight? So here we are doing a little operation with decimals. Okay, so you want to know the difference between the two gentlemen. The difference means subtraction. So in here, Larry, the heavier guy, weighs 83.09 kilos. And you want to subtract that by what the other person weighs. So decimal under decimal, 78.347. Okay, notice you have to add a 0 here so that they all are the same size. Okay, you only do this for subtraction or addition. Now you subtract. 9 becomes an 8, 10, that's a 3, that's a 4. You need to be a little borrowing here, so that 3 becomes a 2. Actually, let's borrow it from here. Sorry, 8 becomes a 7, that becomes a 13, which then becomes a 12 because you're giving 1 to this guy. So there. Now it's a 7, and 12 minus 4 is 20 minus 8 is 4. The difference in weight between the two guys is 4.743 kilograms. Okay, just a little practice on operations with decimals. 5. There's a bag of 315. Ooh, wait a second. 45% of the marbles in the bag are red. If there are 315 red marbles, how many total marbles are there? Okay, so let's see how do we approach this one. Okay, so this one, okay, you're probably better off using a percent proportion. Okay, so you know 100 goes here, and 45% is the number you're going to put on top here. Okay, so remember it's percent over 100, and I'll just write this part over total. Okay, that's what should go on the part should go always on the top, total at the bottom. So out of 100, as far as percent goes, out of 100, 45% are red, and on the other side we're going to write its equivalent. So the other number that we have is that 350 red. There are 315 red marbles. Okay, 315 represent parts of the bag. And what we're trying to find out is the total amount here. We'll use a question mark. Okay. Remember when we did ratios? It's the same exact thing. So see if you find a relationship going this way, because those two numbers are the only ones that you can work with. So 315 and 45, is there a relationship between 315 and 45? And let's find out. I believe that might be 7. There's it, yes it is, times 7. So 45 times 7 is 315, so you're going to apply that same factor at the bottom. So 100 times 7 is 700. So one way of saying this is that 45% of my bag is full of red marbles, or 315 out of a bag that has 700 are red. Okay, this is a little flashback for you guys, okay, because you haven't done this for a while. 6. Create a model to determine the solution to 4 divided by 3/5. Well, 4, okay, ugly 4 divided by 3/5. Alright, so what are you being asked? Remember, you're being asked how many times can 3/5 fit into 4. So let's draw 4. That's 1 chocolate bar. Okay, that's 2 chocolate bars. That's 3 chocolate bars. One uglier than the other one. That's 4 chocolate bars. Okay, and you want to divide this by something that's been cut into 3 pieces. So the question is, how many times can I fit these 3 into here? Well, my chocolate bars haven't been cut yet, but I'm going to cut them now. So because the denominator here is 5, it helps if I cut these guys in 5 as well. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So there you go. I have 4 chocolate bars. Okay, they've been cut into fifths, okay, which makes them exactly the same size here. I can easily see how many times these fit inside. So let's count how many times these three can fit. I can make one group of three right here. I'll just draw a line here. So that's one. You can fit one time. And I'll count 1, 2, 3 up to here. That's 2. Then another 3. 1, 2, 3. So that would be 3 times that it can fit in. And then 1, 2, 3. That would be 4 times that it can fit in. And then 1, 2, 3. That would be 5 times. And then 1, 2, 3. That would be 6 times. I can fit these 3 guys in here 6 times. And then I can also fit in the first 2. This one and this one can go in here and here. So I can fit the next 2 out of the 3 that I've been trying to fit in. So 4 divided by 3/5 equals 6 2/3. Okay. Alright, a pound of kale, it's a very good vegetable, sells for $2.28 a pound. Tina buys 5.28, 5 pounds. How much does she pay? Actually, how much change did she get if she paid with a $20 bill? Well, let's see how much the total is. Well, 1 pound is $2.28, so 2 pounds would be double that, which is $4.56. 3 pounds would be triple that, which would be $6.74. No, 78. Sorry, 3 pounds would be 3 times 24, 6.84, and so forth and so forth. I can do it that way. That's going to give me a problem later on. Or I can just simply multiply. This is 1 pound. How much it costs for 1 pound. Multiply by how many pounds I bought. I bought 5.25. Okay, so I'm going to multiply 2.28 times 5.25, and you should get an answer of $11.97, which is what her total is. But she takes it to the register. She gives in a $20 bill, which I'm going to add a decimal and 2 zeros, and I'm going to subtract what the price of kale. And let's borrow. 2 becomes 1, that becomes a 10, which becomes a 9, that becomes a 10, which becomes a 9, that becomes a 10. So that's 30.8. So $8.03 is how much she gets in change. Okay. 8. Winter coat's priced at $135. The tax is 8%. What's the final price? So remember, tax is something that you add to your bill. So here's the price of my item. So that's the coat. And like anything else, you have to pay tax on that. So tax is based on the price of your coat. So we're going to find out what the tax is. So it's 135, and we're going to take a piece out of the 135. Okay, which is in this case 8%, or remember, as a decimal is 0.08. Okay, so that's a 40, goes 428, goes to, so your decimal, and I forgot to do this, I should have done, there's no decimal places here, there are 2 decimal places here, which means if I add those 2, it's 2 decimal places, which tells me my answer should have 2 decimal places, so I'm going to put the decimal right here. So my tax, which is 8% of 135, which is a little part of 135, is $10.80. Let me line up everything here nicely. 135 doesn't have a decimal, so I add it to the end. And I get added up 0.85 for $145 is what I'm going to pay at the register with 80 cents. Okay. 9. There are 75 dogs in the farm. 40% of those. So 40% of the 75 dogs are beagles, and we want to know how many are not beagles. Okay, so first we have to find how many are beagles. So 40% of 75, that's how many dogs are beagles. So in this case, let's find what 40% of 75 is. We change that to decimal, 0.4 times 75. Okay, and if you actually do that, you should get about 30. So 30 out of the 75 dogs are beagles. So 30 dogs 30 of them are beagles, which means 45 are not beagles. Okay? No, that's that. 10. Tim had 11/12 of his apple pie left. His younger brother secretly ate 5/9 of that pie, that he had. How much was left? Well, it's a subtraction problem. This is how much the older brother had, and this is how much the younger brother took. Okay? When subtracting, if the denominators are different, we're going to find their equivalent, okay, by finding the LCM. So we're going to change both to a fraction of 36. We're not changing the quantity, we're just, it's much easier to subtract when the denominators are the same. So 11/12 becomes 33/36, and this becomes times 4, 20/36. Now I can subtract, and I get 13 out of 36. Okay? So that's how much he had left over after his younger brother took 5/9 of what he had. Okay. Let's see. The area of the living room is 32 meters squared. It will cost $2,045 per square meter to carpet the room. Okay. On one I said meter squared, and the other one I said square meter. I like to say meters squared. I don't know why I wrote it two different ways. So let's just use square meter. Okay. So let me do a drawing. It's not going to be obviously a real representation, but you can get the idea. So here's my living room. Okay. So a meter, imagine a meter being the height from the floor to the doorknob. So if you're looking at the floor, imagine a big box, right? A big box, because the meter is pretty big. So a box that goes 1 meter this way, 1 meter this way, 1 meter this way, 1 meter this way. Okay. So the area here is 1 meter squared. So if I'm looking at my floor, it will take $2.45, okay, for me to pay someone so that they come here and carpet that particular area. Okay. So that's $2.45. That's $2.45. That's $2.45. That's $2.45, and so forth and so forth and so forth. Okay. So it's $2.45 for 1 meter squared, but I don't have just 1 meter squared in my living room. It's a little bit bigger than that. It's 32 meters squared. So this one is just a simple multiplication problem. So 2.45 times 32 equals, I'm going to end up paying $78.40. Okay, which very cheap. 12. Find the value of n for each of the following. So this one, you know what? I'm going to use fact families, and I think everybody has heard of them. N minus 1 over 4 equals 5 or 12. All right, that's your problem. And we want to find out the value of n. How much is n? So what number out there can I substitute n with? Okay, subtract 1/4 to give me 5/10. Well, before I actually do that, let me do something here on the side. Let's take a number like 8 minus 2 equals 6. Let's practice our fact family with this particular sentence. I can also say 8 minus 6 equals 2. I can say 2 plus 6 equals 8. And I can say 6 plus 2 equals 8. Okay, that's how you do fact families. Remember? So let's do that same thing with these numbers. So first thing I'm going to do is I can say n minus 5 over 12 equals 1/4. What else can I say? I can say 1/4 plus 5 over 12 equals n. And I can say 5 over 12 plus 1/4 equals n. Notice that I did the same thing here on this side as I did here. Okay? Now, what do you think, or which do you think I can use to find the value of n? Can I use this one, or this one? Well, I'm hoping you're going to say either the third one or the fourth one. If I add these two, I will get the value of n. So let's take this one right here, 1/4 plus 5 or 12. Well, 1/4 plus 5 or 12, I'm going to use the LCM because I'm not going to add them as they are. So 1/4, I change the 4 to a 12, so I multiply 4 times 3, so therefore I have to multiply the top by 3, which gives me 3. And this is 5/12. So my answer is 3/12 plus 5/12 is 8/12. Okay, so this is what goes in here. So now I'm going to erase this because I'm going to run out of room. So I found how much n is. Okay. Well, let's see if that is true. Is it true that 8/12 minus 1/4 equals 5/12? Well, let's see if we did this right. So 8/12 minus 1/4 equals 5/12. Well, it has to be true in order for our answer to be true. So again, need to find the LCM. This is 12. And I'm going to change the 4 to 12. So this is 5. This is times 3. So I multiply the top by 3. So 1 times 3 is 3. Equals 5/12. Oh, look at that. 12 stays the same. 8 minus 3 is 5. So 8/12 was actually the number we were looking for. Okay. So the next one is not going to work because you're going to have to deal with negative numbers. I made up a little mistake. So what I'd like you to do is make this 2/5. Okay, so I'm going to copy the question. And we're going to change this number here to, I don't know, let's make that 13/20. Okay, so it's not the problem that's on the sheet because that deals with negative numbers and you still haven't done that. So if you can want to press pause, you can press pause, okay, and then come back and see if you can do it. So what I suggest you guys do is, again, just practice your fact families like here on the side. So take 3 random numbers. I chose 8 plus 2 equals 6 and do them. Alright, so press pause, come back. Alright, so if you already did it and you're coming back, so fact families, 8 plus 2 equals 6. I can also write 2 plus 8 equals. Why did I write 8 plus 2 equals 6? Because obviously it is very late and I should be sleeping. But hang on. So 8 plus 2 is actually 10. There we go. And 2 plus 8 is 10. Now what else can I write? I can also write that 10 minus 2 is 8. And I can also write that 10 minus 8 equals 2. Those are the fact families that I can come up with from our original statement here. So on that side, I'm going to do the same thing to see if there is another way of an expression to help me find what this n is. So I can also write n plus 2/5 equals 13/20. Now that I have, it's always 2 additions to subtraction, or later on you'll see it's 2 multiplication to division. So I can also say 13/20 minus 2/5 equals n. Ooh, and this is probably the one we want to use. Or I can say 13/20 minus n equals 2/5. Now, which one do you think is going to help you with finding the value of n? It's this little guy right here. Okay, why? Because the n is all alone by itself, it's isolated, and by doing 13/20 minus 2/5, you actually get what n is supposed to be. So, in this case, let's subtract 13/20 minus 2/5, and you're going to get, well, you're going to have to change first. Denominators are 20, one's already at 20, this is times 4, so top by 4, so you get 5/20. Okay, so there is our answer. So we can double check to make sure that that is indeed a true statement. So let's go back to our original fraction. and see if that really is true. So it says 2 over 5 plus n, which in this case we know, we just found out it's 5 over 20, equals 13 over 20. Let's see if that is true. Okay, so on the left side, the denominator is a 20. That's already a 20, so nothing can be changed. This is times 4, so the top's times 4. 8 over 5, and you can tell 8 over 5 plus 5, I'm sorry, 8 over 20 plus 5 over 20, it is indeed 13 over 20. So we were absolutely correct. So your final answer was 2/5. That was the value then. Next one, n times 4 over 9 equals 12 over 63. You can do fact families here too, or you can just, for a second, this one works out nicely. You could have done this. Take out the n and write a fraction. So, what numerator do I have to put in here so I can multiply by 4 to get 12? Obviously, 3. Same thing, what denominator do I have to put at the bottom so I multiply to get 63? Would be a 7. And there is our answer for this one. Okay, that's the really, really, really easy way. Okay, and the only reason it worked out is because your product was a number that can't be simplified. Okay, so that you run into trouble sometimes. Next one. 5 divided by 3/5 equals n. You don't need to do fact families because look, our n is already all by itself here. Okay, so in order to find n, you actually have to do 5 divided by 3/5. Okay, so in this one, just because I want you to get a visual practice as well, I'm going to do it both ways. So the first way is by multiplying by its reciprocal. So you get 5, and you put it over 1, change the division to a multiplication, and you flip or find its reciprocal, which is 5 over 3, and you get 25 over 3, which is 3 goes in 25 8 times, left over of 2 out of the 3. That's your answer using multiplying by its reciprocal. Let's do it with pictures. With pictures, you have 5 boxes. 1, 2, 3, 4, 5. And divided by this. So you are asking yourself, how many times can something that was cut up into 5 and you only have 3/5, how many times can these 3 guys fit into these 5? Well, easiest, what you should do is obviously cut these in 5s as well. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And if you can do a better job than me at drawing, please, by all means. And 1, 2, 3, 4, 5. Alright, so how many times can these 3 fit into all those? Okay, so let's do this using red. That's what it means. So you can fit 1, 2, 3, that's one group right here, 1 time. 1, 2, 3, and that's 2 times. 1, 2, 3, that's 3 times. 1, 2, 3, that's 4 times. 1, 2, 3, that's 5 times. 1, 2, 3, that's 6 times. 1, 2, 3, that's 7 times. And 1, 2, 3, there's something wrong. Oh, that's 8 times. Okay, so you can fit it. You can fit those 3 8 times, and guess what? You can fit one more piece, which is this one over here. 1 out of the 3. There's nothing wrong. I just made a mistake on this side. 3 goes in 25 8 times, which is 24. 1 left over 3, which is exactly what we had here on the picture. Okay. 13. The distance to my house from my house to the park is 3.5 miles. If I can walk 4/5 of a mile in an hour, how long will it take me to reach the park? Okay, solve. Right. By providing the following model, number, sentence, and answering the question. Alright, let me do a very crude, a very basic picture here that, and I'll do a better one with boxes. So this is my house right here, and I have to go to the park. That's 3.5 miles. Okay. Now it says that every time I walk 4/5 of a mile. So pretend this is 4/5 of a mile right here. Okay. It's not to scale. It's nothing. It's just trying to see if you guys give you a visual here. So if I walk 4/5 of a mile, it's 1 hour. I walk another 4/5 of a mile, it's 2 hours. I walk another 4/5 of a mile, 3 hours, and so forth until I reach the park. So notice that I'm trying to see how many times 4/5 goes into 3.5. So a number sentence for this particular problem is 3.5, which is the distance from my house to the park, divided into 4/5. Okay, so every time I walk 4/5, it's an hour that I just walked. So try to find out what the answer to that is. Now, remember from class, in division, when you divide, you want to make sure that you're dividing, especially when drawing models, that your denominators are the same. Okay, so in this case they're not. Okay, and we want to change them so that they are the same number. So the first thing I want to do is change this to an improper fraction, which gives me 7 out of 2, and divided by 4/5. I have done nothing. I haven't changed the problem. I just using equivalent fractions. So I can say it like that. And now I'm going to change it again one more time. Okay, found the LCM, which is 10 times 2, so it's 8 over here on top, and then times 5, which is 35. So now my denominators are the same. Much easier for me to visualize how many times 8 can go into 35. Okay, remember, when the denominators are the same, you literally, this can be crossed over, and it literally becomes a division of 35 divided by 8. Okay, so let's draw this, because that might be the difficult part of the problem. 35 tenths. Well, you have 35 pieces, and they're all 1/10 size each. So what does that mean? Well, let's see if I can get that in 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm going to take a shortcut here because my drawing skills are horrible. I'll clone that. And that's another 10 pieces. And I'm going to clone that. So now I have 30 pieces that are 1/10 each. And I need one more because I have 35, so I'll clone that again. Okay, there. And then I'm going to actually clone this one more time. And clone this. Come on, clone. And I'll put this on this side. Alright, so this is what my division problem looks like. And let's color in. Alright, so on this side, I'm going to do 1, 2, 3, 4, 5, 6, 7, 8. So how many 8/10 can fit in 35 tenths, by the way? Oh, I actually shaded it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2, 3, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. There you go. 35 pieces, and they're all 1/10. That's 1/10, that's 1/10, that's 1/10, that's 1/10. So I have 30 pieces that are 1/10 size each. Now I want to see how many times 8/10 fit into 35 or 10. So you can do it 1, 2, 3, 4, 5, 6, 7, 8. So there, it fit one time. That's 1. 1, 2, 3, 4, 5, 6, 7, 8. That's 2 times you can fit in there. And then 1, 2, 3, 4, 5, 6, 7, 8. And that's 3 times you can fit in there. And then 1, 2, 3, 4, 5, 6, 7, 8. And that's 4 times you can fit in there. So I can fit it 4 times. And then I can still fit in 3 more pieces out of the 8 that I've been trying to put in. Okay, and that's my final answer. You can always double check your work. So 35 over 10 divided by 8 over 10. You can actually do it via multiplication, and that stays the same. You're multiplying by the reciprocal, 10 over 8, and you get 350 over 40. Okay, and let me cut these zeros out. Okay, so 350 over 4, which is indeed 8 and 3/8. So your model, oh, sorry, did I write 8? Whoa, 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 whoa. La, 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 la. No, 10 times 8 is 80. This should have been an 80 at the bottom. So it should be 4 and 2/3. Okay, which is exactly what we got from our model. 4 and 3/8, I'm sorry. Okay. And finally, oh, not finally, two more. So Jean bought 5/6 of a pound of whole wheat flour. It takes 1/4 of a cup. So she bought this much. So blah, blah. How many loaves of bread can she make? She bought a quantity of flour, and it takes little cups to make 1/4 of a cup to make one loaf of bread. How many loaves of bread can she make with that whole bag of wheat flour that she had bought initially? So the number sentence. For number sentence, this is a division problem. So you have 5/6, and you want to see how many times 1/4 goes in there, which is division. That's your number sentence equals. Let's stick to n. Now, to do our model, do yourselves a favor. Okay. You're gonna change it to LCM of 12. Okay, that's 10, and that's 3. Okay. When you multiply the reciprocal, you don't need to change it to the LCM. You can just go 5 over 6 times 4 over 1, and you get 20 over 6, which simplifies to 10 over 3, which simplifies to 3 1/3, which is hopefully what we'll get from our drawing. So we already know ahead of time that our answer should be 3 1/3. Well, okay, so when you're multiplying, you don't need to find the LCM, okay? Please remember that. So when you're drawing the model, you want to find the LCM because you want to have the same pieces of the same size. Okay, it's much easier to do the answer, draw the model. So here's something that's cut into 12. Again, you didn't change the value of anything. Okay, it's still 5/6. You just found the equivalent fraction, which is 10 over 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 over 12. Okay, and you had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you have 10 12ths of a bag of flour, so not a full bag of flour, very close to the top. And you want to see how much something that also was cut into 12ths. Okay, and you have 3. So it takes 3 of these 3 12ths to make one loaf of bread. So how many times can this fit into the top part? Well, here's my first loaf of bread. Here's my second loaf of bread. Here's my third loaf of bread. So I can make 3 full loaf of breads and 1 piece out of how many that I'm trying to put in there? 3. I can make 3 1/3 loaf of bread with that. Okay. And last question. Oh, last question, the easiest question. 5 over 6. No, we stopped that. 5 over 6 divided by 2/3. Okay, you're asked to use multiplication, but to do the problem using multiplication, which is obviously multiplied by its reciprocal, which is 5 over 6, times 3 over 2. And if you multiply this out, you get 15 over 12. You can simplify now, you can simplify after you change to a mixed number. I think it's easier to do it now. Divided by 3 is 5, divided by 3 is 4, and which gives you 1 and 1/4. Okay, that's that. And so if you can do these questions, you should be very, very okay on the test. If you have any questions, please email me. Let's make this interesting because I have a feeling that a lot of you are watching these. On Monday, anybody who dresses up with mixed, what's the word I'm looking for? Unmatched socks, is that the word? or mixed socks, one is black and the other one is red, as long as they're not the same. Okay, let's make this interesting. Okay, just to see how many of you are actually watching this video. So if you come as mix match, I forgot. As long as your socks are different. If your left one is different than the right one, they're different. Whether one is striped and the other one is not, the one is yellow, the other one is pink, I don't care what it is. As long as they're mixed match, I don't know, I'll give you a little bonus on the test. Okay? So that's that. If you have any questions, email me and I'll do it again and I'll put another video or I'll answer it however I can. Okay? That's that. Have a good weekend and I'll see you Monday.